This is Dustin Headley, and I work for the Institute for Digital Fabrication, and this tutorial covers prepping 3D models in reRhino3 for 3D printing. Okay, so what this is, I already have a file open, and this file is a pair of sunglasses that I'm trying to develop and prototype. So what I've done here is I initially started out using the Z-Core 3D scanner to take an existing pair of glasses so I can start to understand the contours that are involved in developing an actual pair of glasses themselves. So you see I have this mesh which I've already started to clean up. You can see it's kind of jagged and also very holy, and this would not be really a good mesh to try and print. So what I need to do to go from here is to rebuild this, and then I'm going to basically go through a number of steps that you'll understand. I'll explain as I go, but basically I 3D printed this on the Z-Core powder 3D printer as a prototype to see if it would fit my face, with the intention of taking this to a ABS plastic printer for the final prototype. So the first thing I needed to do is, this is actually really chunky, right? And so I'm also not oriented properly. So the first thing I did is I came in here and I reoriented it appropriately. So now we can start to kind of have a better perspective on how this thing is supposed to look. And I'll just turn this off as we go. So now we can start to see, and if we go in here into the shaded view, this is obviously very pixelated and low res, but this is actually just acting as a guideline. I only need half of the image because these glasses are symmetrical like most glasses. So, alright. So from here I developed a series of curves on top of the model using the mesh from the scan as an existing kind of framework. So I started tracing these out and outlining them, and in doing this I did a little bit of redesign and based on what I wanted to accomplish out of the design itself. So I simplified it in short, and I also made this a little bit more compressed already. Alright, so then after I developed these curves, which go over here and take a look, we can see that now I have some kind of very kind of smooth geometry to develop some kind of surfaces. So when I turn on this, we can now see the surfaces that were developed. So if I move this out, I'll just copy. Yeah, I'll turn on the shaded region. We can now see that this is the developed earpiece, and this is the developed eye socket. And so then these two pieces come together, and I've trimmed out and set this up for a mirroring operation. So now here's the mirrored geometry, and this is now all NURB surfaces. And so now this is, press escape and exit that view. This is all stuff that I can manipulate. Okay, so now the thing to understand here is that each one of these guys is developed from a very specific geometry, and each one is closed. So each one of these units is a closed watertight object. So, and I can show you how to do that in here very quickly. So if I take and start lofting these guys together, oh, sorry, wrong curve, maybe not. Tell you what, let's go over here. This is the original geometry. So I can take and start lofting these guys together. And the thing you want to consider, actually you want to rebuild these. When you start to build this kind of geometry, sometimes like I have these kind of weird kinks, so I'm going to rebuild this geometry so that each one has the same number of coordinate point counts and is of the same degree. Actually, let's do it again. We'll drop this down to something like 7. And you see it simplifies the curves a little bit, but now what that accomplishes is now when I loft this, no matter how many points were used to develop it, it's going to regenerate something that's going to be very even all the way across. So this is going to be very calculated. And if I undo all that, I might be able to show you what I mean. Okay, and see how this geometry starts to reach across and down. That often causes sort of deflection in the surface. So if we're rebuilding these things, we can avoid that altogether. So now I'll just take this, loft, this, loft, and I'm going through this rather quickly because that's how it's got to be. Alright, so then we can take these edge curves and loft them. Now you can see how we're starting to develop this kind of watertight geometry by using the same curves. So when I take these and I can join them together. And then now this is now a watertight edge. And what you want to do is you want to create an enclosed volume similar to like creating a box. This is a very 3D printable, although clunky, object. Alright, so then what I want to do after I develop these surfaces, I need to go back into a mesh model. So I've developed this geometry and I prototyped it. After talking and getting a little bit of critique, I ended up trimming out the nose, so I versioned this a couple other times and I created this kind of nose trimming operation, and this was the final model that got 3D printed. So you can see right here, if I do a select closed mesh, I can check, and this is how this object is a closed mesh. If, for example, I wanted to test to make sure my poly surface was closed, I can do a select closed poly surface. Now all those are closed poly surfaces. And when you mesh, something like the mesh command, you're going to do this. It's going to create a mesh. It's going to think. We're going to pull this away. And see here we have this mesh. We want to analyze the mesh and do it by doing a select closed mesh. We can ensure that our mesh is printable and watertight, because sometimes when you export this, it becomes an open geometry just by nature of your tolerances in the file and all that. Okay, so that's essentially it. And then just one other note that one other thing that I did in this sort of process is I prototyped it, and at one point I was exploring doing a mold. So what I did is I created a geometry around this geometry, around the glasses, and I trimmed it out and gave it these kind of breathing holes, which ended up being inadequate. But principally you get the idea how this machine can begin to produce objects, not only in and of themselves, but objects that you can then create other objects from. So, and this, while this prototype didn't work, it needs to be revised in a couple of locations. The geometry in this was sound and the principles were sound. So, it's just something to think about. Alright, cheers.